Hi everyone, my name is Sanjay Chouhan and welcome to my YouTube channel. In this video of Maths for Machine Learning, today we'll be discussing about vectors. Vectors are very important concept in machine learning. They are used to represent data points. So basically the first thing that you use is vector because you need the data, right? So I will see what is a vector, how to represent the vector, and how vectors differ from points because sometimes they are confused. So we'll see how they are different from points. Let's look into what is a vector. A vector is a quantity, okay, which has magnitude and direction. So it has two things, magnitude and direction. Magnitude is the length and it has a direction. We use vector in maths and physics. In physics, we use to represent velocity, force. Force will have direction, it will also have some magnitude. So we use vector to represent force. In machine learning, we use vector to represent data points. We'll see how it's used. Let's first look into what is a vector. So this is a 2D plot, 2D graph, where we have two components. This is X and this is Y. Okay, we have two components. We have 3 points here, point A, point B, point C. Okay, and we also have the origin, which is 0, 0. So the coordinate for origin is 0, 0. The coordinate for point A is 1, 2. The coordinate for point B is 4, 5, and the coordinate for point C is 3, 3. You can see in the graph as well, and here I mentioned. When you connect two points with an arrow, you get vector. Okay, so here we have, so these arrows are vectors. So let me, um, so this is a OA. This is a vector OA. Let me create this. So this is a vector. Here we have a direction. This arrow represents the direction. And we have a magnitude or length. So this whole length of this vector OA, this is the magnitude of this vector. Okay, this is vector OA. We have other vectors like this is OB, the green line. This green arrow is vector OB. So it's starting at origin O and ending at point B. Okay, and the direction is this in direction of B. Similarly, this is another vector OC. So vector need not to be starting at origin only, vector can start at another point as well. So this is another vector AB. Okay, this is a vector AB which start at point A and end at point B. So this is the vector. So the vector doesn't have to start at origin. It can start at any location in the graph. Okay. So the value for vector OA is 1, 2. We are using this square bracket to represent the vector. Okay, and to represent the vector, we need this arrow on top of the name. So this is the name of the vector OA. Okay, and we are using having this arrow on top of it to represent this is a vector. And to contain the value, we are using this square bracket. Okay, we're having x component and the y component for this vector. So this x component means how far we need to go in x direction. We are going 1 unit, and in y direction we are going 2 unit. Okay, so this is a, so this is our OA vector. It's same as the coordinate for point A. And so vector which are starting at origin, we generally omit the O and use the point names. Like here we are omitting the O, and it's like we will use only A to represent this vector. Instead of OA, we can say A. That's like a general rule. It's not a hard guideline, but in general, you will see in textbooks. Similarly, this OB, we can use just B to represent this vector. And the value for this OB vector is 4, 5, which is the same as the coordinate of the point B. And for this C vector, which is also OC, the coordinate is 3, 3. Okay, so which is same as the point coordinate of the point C. So these are the first and second component of this vector C. What about the vector AB? Okay, what is the x and y components of the vector AB? Since the vector AB is not starting at origin, um, we need to start from A. We can't start from here, origin A. Sorry, origin. We can't start from origin O. We need to start from A and see how much we need to go in x direction. So for this, we clear everything. Okay, so for this AB vector, right? This is AB vector. We are starting from A because this is in the this direction. So we are starting from A and we are going till B. So we are going 3 units in x direction, okay, and again 3 units in y direction. So the components of vector AB is going to be 3, 3. Okay, see, this is 3, 3. The same as vector C. So vector C and vector AB have the same value. And why is that? It's because if you see the direction of vector AB and direction of vector OC are same. So they are parallel. And also the length of vector AB and length of vector OC are same. So that's why they will have the same value. Okay. So it doesn't care about where are you starting. You can start at origin, you can start at any other location. It only captures the magnitude or the length and the direction. Okay. So that's why the vector AB and vector OC or C have the same value. We'll see the calculation of vector AB in the next slide. So we saw that we are representing points like this, right? This is the coordinate of this point A, it was 1, comma 2. And we are using this A and the arrow to represent the vector A or OA. So there are two representation of vector. There is one called row representation and another one is column representation. So in the row representation, we will have the components in horizontal order. So here having 1 and 2 in horizontal order. And in the column representation, we'll have the components in vertical order. So this is the first component and this is the second component for vector A. So this is two representation. We usually use the column representation mode in the machine learning, and we rarely use the row representation. Just keep in mind. And now we saw that the value for vector AB was 3, 3. We saw in the graph, right? How we calculate it. We can also calculate this from subtracting A from B. So we have the vector B and we subtract A from the vector B. Basically, it starts at A and it goes to B, right? So that means we can subtract A from B. We'll get the vector AB. And so for B, it was 4, 5, right? The component, the vector B is 4, 5, and vector A is 1, 2. So if you subtract 4 minus 1, you'll get 3. Right? So 4 minus 1, you'll get 3. And 5 minus 2, you'll get 3. So that's how we get vector AB, which is 3, 3. Now, yeah, we saw this that AB is equals to C because they are, I mean, they are equal and have the same magnitude and direction. So their length is same and direction is same. So we have AB is equal to C. We have seen this in the graph as well. Now there is one more vector that we can get, that is BA, by subtracting B from A. Okay, so this is in reverse direction. BA is in reverse direction. Uh, so you'll subtract B from A. So A is 1, 2, and B is 4, 5. So 1 minus 4, you get minus 3. 2 minus 5, you get minus 3. Okay, so the BA vector is minus 3 and minus 3. Now, the AB and BA have the same magnitude but reverse direction. So values are exactly same, right? 3, 3. I mean, if you do not consider the sign, the values are same, 3, 3 and minus 3, minus 3. So they will have the same magnitude, but the direction is in reverse. Because if you multiply minus 1 into this vector, like if you multiply each component of this vector with minus 1, you get the vector BA. So that means it's in reverse direction. So uh, we have point A and we have point B, right? We have this point. So AB was like this, and BA will be in reverse direction. Basically, it will start at B and end at point A. So this is our BA vector. This is our AB vector. So these are vectors. We'll see how it's used in machine learning. Thanks for watching. If you have any queries, please let me know in the comment and please like and subscribe.